The construction of Kenya's first coal power plant is waiting on a ruling from the country's environmental watchdog. The construction of the near 1,000 megawatt power plant in the coastal town of Lamu has been challenged at the environmental tribunal. For a look at how the power plant's designers worked to mitigate both chemical and thermal pollution, I spoke to Sanjay Gandhi of Kurrent Technologies. I started by asking him how the thermal pollution problem on the coastline can be alleviated.
And what we've established is that through the modeling studies, we can actually come within 3 degrees Celsius of the differential temperature over a radius of perhaps 50 meters from where the outlet is located. So from that perspective, the supercritical technology that we modeled initially this project on actually meets the World Bank's environmental standards and guidelines with respect to the thermal discharge or the thermal pollution that is going to be discharged by this power plant. So when we look at that perspective, we're not really damaging the marine flora or fauna as long as we have a theoretical zone of mixing that takes place where the water is discharged from.
Right, so when you do that sort of modelling,
Yes.
is South African coal the reference point that we start with? Because I believe in the RFP it was a question of, do we use what we have available, which was not at market at the time, it still isn't because we haven't started mining at scale, or do we simply use what's easily available on commercial scale in bulk, which is essentially from South Africa, a couple of days away by ship?
Yeah, so again, as you correctly said, as far as our Kitui or Moi Basin coal is concerned, we're still in the exploration phase of that coal. When we get into the mining phase, we'll see whether we can actually move that coal in bulk and what's the best way of moving that coal in bulk to the location of the power plant. If it's going to be an expensive affair to perhaps build a railway line, for example, all the way from Kitui to Lamu, then we've got to work out the economics, as far as this coal is concerned. When the RFP came out, there were 3 types of coal, as I said. One of them was the Kenyan coal. So it was a consideration that we could use the coal, and therefore the contractor that won the project, in this case Lamu Power, was told to make sure that the design could take any one of those coals, reference coals that were provided in the RFP.
Effectively future-proofing it.
Yes. So the power plant is being designed to take in Kenyan coal in the future, should it be available, in bulk at the site.
What about the emissions side of it? Going back to the coal question, to what extent does the coal we use as our input fuel determine what comes out of the stack on the other end?
It depends on the type of air quality control systems that are being put in place. Fortunately, the location where we've got the power plant and looking at the weather patterns, in other words, the wind data that has been collected for the last 5 years, that is what went into the inputs when we're doing the modeling. What will the ground level concentrations look like? So if I have a good design coal that I use, then obviously, and I put in place the right control units as far as air quality control are concerned, then what I'll be able to emit on the stack and what settles eventually at grade level are very minute levels of whether it's sulfur oxides or nitrous oxides or carbon monoxides and so on and so forth, or particulate matter. So the modeling that we've done for this particular coal power plant using the reference coals that we had initially all indicated that the ground level concentrations of the pollutants were well below the World Health Organization requirements. They were well below the International Finance Corporation's environmental guidelines for thermal power plants, and they're also well below the Kenyan national standards for air quality in as far as our regulations are concerned. So we benchmarked the modeling results with 3 criteria, and we also, fourthly, benchmarked our air quality criteria with the European ambient air quality standards, and we found that all our results, based on the specifications of the boilers, based on the specifications of the coals that we use, and we modeled it on the worst case scenario coal, which happened to be the South African coal that we got. We found that our modeling results based on the design of the power plant will be able to meet any one of those criteria.